They do so many other things in a weird way that I never want the default behavior to be the thing that it does. Now it gives me this number, and it doesn't put it in scientific notation, but we could count 1, 2, 3, 4, 5, 6, 7, right? So the answer I get is that it's 42, I'm going to say 42.15 times 10 to the 6th meters. And I'm doing that just for fun. I'm not writing it as 10 to the 7th meters. And that's because the radius of the Earth is on the order of 10 to the 6 meters. Yeah? Is everybody able to get their calculator to say just that? Well, look what I did and look what you did. And see what's different. Because that's the right answer. So write it down. If this was not obvious to you that that's how you typed it in, then... Do you guys know that you can edit something? If you screw up and hit enter, you don't have to type the whole thing over again? Right? You can go second entry and go, oh, and then go up in here and go, oh, that's 86164. Second entry, right? Enter. Second entry barks it up, then you can take the arrow keys and move it through there. Yeah, second entry is one of the single most powerful things that these calculators do. Right? Well, now they're getting sassy. They're like putting like radicals over the things, right?
Now you can like, now it's crazy.
But then the radical becomes like this booger that you can't shake off. It's like, no, I don't want that to be another radical. It's like, no, it is. You know? You have to do something. I don't know. Okay. Now it's hard to wrap your mind around a number as big as 4.215 times 10 to the 7th meters, right? That's kind of big, right? So the question is, how many Earth radiuses is that? Because that's something we could wrap our mind around, right? An Earth radius is like this. So just for fun, you don't do this generally with problems, but just for fun, divide by 6.38 times 10 to the... I wish I could type E, but that doesn't work. 10 to the 6th, right? And this gives you Earth radii away from Earth. Is it about 6.6 Earth radii? Yes, it is. So picture this, okay? The space shuttle, or the space station, which is really pretty far away, the space station is 250 miles, which is a quarter of 1,000, and there's 4,000 miles of radius, right? So that's a 16th of the radius away from the Earth. So that's like here. I don't know, what's a 16th, but there it is, right? Okay, so the space station's here, but a geostationary satellite, and there's a buttload of these, right? If you look at a map of all the orbits and all the satellites, the geostationary orbit is just chock-a-block. Everybody's got a satellite there, right? That is 6.6 Earth radii. So here is one radius. Now we are 2 from the center, aren't we? 1 above the surface of the Earth, but 2 Earth radii from the center. Now we're 3. Now we're 4. Now we're 5. Now we're 6. And 6.6 is like here, isn't it? Yeah? Kind of like there. And so let's put our eye there. It's like, Kevin's like, he is uncomfortably close to me. Okay. That's how big the Earth looks from that satellite. That's way the hell and gone, isn't it? Is that maybe why, there's two things, right? Is that why you need like a concentrator dish to concentrate the signal from this, even if it's a fairly robust signal? You're pretty far away, aren't you? You're not, not relative to the moon, but relative to Earth, pretty far away. The second thing is, if they start to put cell phone stuff out there, that's not really going to work too well, is it? That's too far away, isn't it? Yeah, you don't want to hold a radio receiver transceiver against your brain that can hit a satellite that far away, right? Let's just say that, right? Okay. I'm not, cell phones might not cause cancer, but that thing's going to cause cancer. Okay. It's going to cook your brain, right? Okay. So that's why when they started doing this stuff with Satellites actually worked with low Earth satellites. Now, the problem with low Earth satellites is that they move zip across the sky. If you sit out at a campfire in eastern Oregon or at the coast where it's dark, you can see those little things that move across the sky. Yeah, there they go. Those are low Earth satellites. Generally, they're spy satellites, are the major ones, right? But there is an array of communication satellites like that. They move across the sky. Is that a problem for cell phones? Yeah, a little bit. You've got to be clever about it, right? The satellites are going to, but they've already got this technology, right? The satellites will have to hand you off satellite to satellite as they move across the sky, right? But if they can track you as you drive 75 miles an hour on I-5, I'm guessing that they can track you as the satellites move across the sky like this. I think that, I think they can handle that. Okay. So anyway, that's geostationary orbit. Let's solve this thing. Let's write down all the solutions for this. This is one of them. This is how you type it into your calculator. Let's do the other ones. Okay. Central body. So let's solve this. What else could we solve it for? How about R? Couldn't we? No, we already did that. How about T? Couldn't we solve it for T? Yeah, let's solve it for T, right? So that's going to be 4 pi squared R to the third equals GMC. Yeah? What's our next step for solving for T? Yeah, divide by General Motors Corp, right? And then what do? Do we square root? Yeah, there we go. Can you take 4 pi squared outside of the radical? Yeah. There's a radical idea, right? Okay. And so that's going to be, they're not laughing at my joke, I don't think. Right? That's crazy. That is T. Right? To do this, this is just an ordinary square root, isn't it? So on your calculator, this is going to look like 2 times pi, I know you don't have to say times square root, just an ordinary square root, right? The radius, caret 3, right? Radius to the third, okay? Divided by, and then this is all in the denominator, so it needs parentheses, 6.67 e minus 11 times the mass, right? Yeah. So write that down. That's your solution. That's how you're going to type it into your calculator. Remember, if a denominator has more than one term, you've got to put those in parentheses. The other option, by the way, is you can say divided by G divided by M. It's one fewer keystroke, but most people don't think that's wrong, so it's not wrong, but it's like back in the day, there is no word flammable. Okay, if something can burn, it's inflammable. Right? You can become inflamed. Okay, but when they started labeling trucks with the word inflammable liquid, people were like, "Does that mean not flammable?" And so, because people were ignorant about the word, they made up a word, flammable, and labeled trucks with it. I'm not pulling your leg. Look this up. It's funny. Okay, it's like those seat belts in the '80s that put themselves on you when you close the door. It's like, zzz. Do you guys ever have one of those? Yeah, people were too stupid to put their own seatbelts on, so all of us had to have cars that had this little thing of zzz, right? Then you like open the door to pick something up and whacks you in the face, right? You know, like you ever do that? Actually my insurance was cheaper because I had those. Way. Okay, and then what else? Couldn't we solve for GMC? So let's do that too, right? So that's going to be 4 pi squared R to the third equals GMC T squared. So what's the next step? Divide by GT squared, right? Yeah? There it is. In your calculator, this is going to look like this. 4 times pi squared times radius to the third divided by parenthesis 6.67 e minus 11 times mass. Yeah? So there's everything you could solve for. This is the world's best cheat sheet, right? You don't need to, if you can do the math, you don't really need this, but you might want to, it's like, how do you type that into your calculator? It's not at all clear. I'm so good at it, not just because I'm a stud, okay? I'm so good at it because I'm a computer science major, and one of the things you have to do when you program is make complex expressions that a compiler can use, and they're all the same. Whereas what? Darn smart-ass kid.